the email ID?
usharengaraju@gmail.com.
Is it REN
GA.
GAREN,
REN.
right?
Yeah.
It's correct. Mobile number
920
hmm?
695
Hmm?
0796.
07.
A session on Keras Core. So Keras Core is a new framework which is a single API which is acts as a multi backend for TensorFlow, JAX, and PyTorch. So am I audible? So this is going to be the topic for today's session. So Keras has always been a multi-backend framework. So if you see back in 2018, it was a multi-backend framework supporting CNTK, and it was also supporting TensorFlow, and it was also supporting other frameworks. But then the other frameworks discontinued, and it started supporting only TensorFlow from back then. Now the multi-backend Keras is back, and this Keras is a full rewrite of Keras. So instead of having 135,000 lines of code, we have just 45,000 lines of code. And you have support for all the multiple backends like TensorFlow, JAX, and PyTorch, and it also supports NumPy. So, if you are an existing TensorFlow user, all you have to do is replace your import statement tf.keras with the that's all you have to do, and you can there's no other code change which is required. So all you have to do is replace your yeah. Thank you so much. So all you have to do is replace your import statement, and everything else will work good. So this is how it looks like. You have a single code base, and then it works in TensorFlow, and it also works in PyTorch, and it also works in JAX. So it is a single code base which works in multiple backends. So this is how the Keras code works. And one more thing about Keras core is, if you want to build cross framework components, you can use keras.ops, and you can write once a single component which will work well with TensorFlow, PyTorch, and JAX. So you don't have to write multiple components for framework specific. You just have to write single component which will work well with all the three backends. And it also supports NumPy. If you see, NumPy is very very fast, especially for pre-processing, certain numerical processing, and inference is also very fast. The only reason we are not able to use NumPy in training is because NumPy does not support accelerators like GPU and TPU, and that is why you have to use NumPy only for pre-processing or any other numerical processing, and you can also use it for inference. And if you want to write custom models, custom layers, custom losses, custom metrics, and custom optimizers, you can also use keras.ops, and then you can build all these custom things. You can just build one component which will work across multiple frameworks like TensorFlow, NumPy, and it will also work with PyTorch and JAX. And so this is how it looks like. Here it's a custom model which is being built, and this custom model and layer, it is just written once in Keras, and it works across multiple backends like TensorFlow, PyTorch, and Jax. It also supports NumPy API, which is a very good thing because NumPy is extremely fast for certain numerical processing, and it is also very very fast for inference. And so if you do not want to write a single component and then use it across multiple backends, and if you prefer to use a backend a framework specific custom component, then that's also possible. So Keras core is quite flexible if you want to write a single component which works across multiple backends, or a framework specific custom component. Whatever your decision is, it allows you to do that. So it's very very flexible. And the one of the best thing about Keras code is a seamless integration with backend native workflows. So you can write a low level Jax training loop, and then you can use Optax optimizer, Jax.grad. It works really seamlessly with a low level Jax training loop, or you want to use a low level TensorFlow training loop, and it also works seamlessly with that, or a PyTorch training loop. So the seamless integration with custom specific components in these frameworks is one of the biggest advantage of Keras Code. So this is an example of how a custom training loop is written using Keras model, and you write the code once and then it works across multiple components. Or if you prefer to write a custom training loop which is very specific to a framework, then that's also possible. So, and in terms of complexity, it can be used by students or it can be used by very complex Waymo engineers. That is something in Keras code for everyone. It's not just for experienced data scientists. I mean, even somebody who is a very novice, like a student, can also use Keras code, and somebody with a PhD and working in Waymo can also use Keras code. The complexity is slowly, but you start with a traditional fit method, and then you can use a traditional callbacks which is already available. And then as you go along, and if you want to introduce a lot of components, then you can also prefer to use custom training loop. And if you want to add much more complex, like you want to use subclassing and all this, there's a lot of support for all of it. So there's a slowly you can keep increasing your complexity, and so it gives you a lot and lot of features to allow you to do that. So this is a sample example of how you can customize your model.fit. Sometimes in certain use cases you can just use model.fit, you do not have to customize it. But certain use cases which are very complex demands you to do customization inside your traditional model.fit. And to do that, Kerasco gives you that kind of a flexibility. So it's very flexible whether you want to write a single code which works across multiple backends, or you want to customize into these specific frameworks. It allows you to do that. And there's also a couple of other frameworks which I would like to highlight is Keras CB and Keras NLP. Keras CB at the moment supports a certain pre-trained models like YOLO V8, Whisper, BERT, OPT. There are only few models at the moment. It's a good opportunity for developers who are listening to this talk. You can contribute to Keras CB and Keras NLP. You can start contributing models like Vulkan, Whisper. There are a lot of language models, open source language models which has come out. Can start contributing these models to Keras CB and Keras NLP. And so there's some of the advantages of Keras code, which is it gives you a lot of good performance. Sometimes in certain use cases, we find PyTorch is very fast, and sometimes in certain use cases, we find TensorFlow is very fast, and sometimes certain use cases, Jax is very fast. So you have the flexibility to choose the framework of your choice, and then based on your use case, if your use case is something which is very much dependent on speed, then Jax or TPU accelerator is your go-to framework, which is very very fast. So whatever your use cases, you can switch between frameworks seamlessly and maximize your performance, which because the Keras core supports multiple backends, and you don't have to rewrite all these components. You can do this very seamlessly. And what if you write a single code and you decide to enter a TF ecosystem? You can convert it to TF save model there. Or sometimes you decide in a single project you want certain use cases to be in a PyTorch ecosystem, then you can convert it into a PyTorch module or a JAX ecosystem. So you can switch on between multiple frameworks, ecosystems seamlessly inside a single project as well. So TensorFlow has only 40 to 60% of the market, but Keras, instead of depending on a single framework, you can go for some, Keras, which does not have any dependency on framework. So some of the frameworks, even if they start support in the future, you can still not, you don't have to rewrite your entire code base. You can still go on without rewriting your entire code base. And at the same time, when it comes for data source availability, you have tf.data, PyTorch data loader, NumPy, Pandas. So it seamlessly works with multiple data sources. So you don't have to worry about having the data set in a specific data format. So it supports these data sources at the moment. And the best thing about Keras core is a future-proof stability. So if you were a Theano user in 2016, you had to migrate to TF1. But if you were a Keras on top of Theano, you don't have to migrate to TF1. The same thing in 2019. If you were a TF1 user, you had to rewrite all your code to TF2. But if you were a Keras user, you just got TF2 free. You don't have to. You didn't have to touch any piece of your code. And now, if you were a Keras user in 2023, you get all three frameworks free and you don't have to rewrite your code at all. So the frameworks keep changing now and then, but Keras may not change. It is very stable, and you don't have to rewrite your code. If TensorFlow shuts down tomorrow or PyTorch shuts down tomorrow, you don't have to rewrite your code. You just have a single code base which will work across multiple frameworks. So you are transient with this. We have come to the end of the session, introduction to Keras code. And if you have any questions, then I can take up the questions. Is there any questions?
Okay.
Yeah.
Do we have any questions?
Yeah. Is there any questions from the audience?
The audience has no questions.
Yeah, yeah, sure. I'd like to thank the TFUG Jalandhar team and for organizing Keras Community Days, and Suraj Mani, the TFUG lead of Jalandhar, for giving me the opportunity to present to Keras community. And if you have any questions at any point of time, you can always reach out to me. And thank you so much for giving me the opportunity.
Thank you, Usha ma'am. It was an honor to host you here.